Hi everyone, welcome to Mr. Carlson's lab. In the previous episode we discovered that all the 4700 picofarad mica capacitors are all noisy, staticky, crackly. And that's all of these micas here. So this one, this one, this one, this one, this one. There's a bunch in the oscillator box as well. They all need to go, so that's what I'm going to do in this episode. I'll get rid of all of these caps and we'll test them once they're removed and see how many of these are actually noisy as well. There's a whole bunch of them that have to go. We discovered that this one here is very, very noisy. That was discovered in the previous one. There's another one down here that should be replaced as well. It seems like all the 4700 picofarad capacitors on the B+ line are the ones that are affected. So it's very interesting. So I have another radio receiver with a different brand of capacitor, and they're micas like this. And I'll open some of those up and test those as well in the other receiver and see if they're noisy. So it should be kind of interesting. I think there was a problem in the production run of these capacitors. I really do. So now there are some subtle changes between this CR-88 receiver and a regular AR-88 and a regular CR-88 receiver, and this is a factory thing. So whoever ordered this radio receiver ordered this with 47 k ohm resistors on the screen grids of the first two RF amplifiers. Now this does not coincide with any schematic that I've come across. So this was some sort of special order thing. Maybe they wanted a little quieter front end, or maybe they wanted more longevity out of the two tubes in the front end, the two RF amplifiers. I don't know. But what they've done is they've put 47 k ohm resistors on the screens instead of the factory 33 k ohm resistors. What that's going to do is that's going to down the screen grid voltage and make the front end of this radio receiver not receive as hard as it normally would. So it's actually kind of making it, I guess you could say it's a little easier on the tubes. But being easier on the tubes, you're also losing some receive. So I'm thinking that maybe this was in an installation where they didn't need a whole lot of receive, or maybe they needed an extremely quiet front end. I'm really not quite sure. So I'm going to replace these again with the factory 33 k ohm resistors because we want the maximum receive out of this receiver that we can get. So I'll get rid of these values here. Again, these are factory. These haven't been replaced over time. So this is some special order thing that they've done with RCA. Kind of interesting if you have one of these radio receivers and you want to quieten down the front end, that would be the way to do it, down the screen grid voltage. That's what they're doing here. So I'll get all of these capacitors that you see here replaced and the resistors, and I'll be back. We'll clean out the band switch a little bit and we'll see how that affects the receive. We'll see if this thing comes to life even stronger than it did before. All the 4700 picofarad capacitors have been changed. So this one up in here, I don't know if you can see that. I hope you can. I'll zoom on in a little bit and I'll turn this thing around. So this one up in here has been changed. See, this one here has been changed. Zoom on in just a touch more. You can see the new 33 k resistor here. And then we have another capacitor changed here, another capacitor changed here, another capacitor changed here. That other 33 k resistor was changed right here. If we look in here, you'll see this capacitor was changed. There's one down in the bottom here that's been changed, down in there. One up here that's been changed. You can see this one right under here. And if you look way down in there, you'll see two little orange bands way down underneath here. Get the tool in there, right down in there. That is another one of these 33 k resistors right here, way down in the bottom here. That was a lot of fun to change. So that one was a little bit out of tolerance. Now I have all the capacitors from each box and I've cataloged them. And what we're going to do is we're going to take a listen to some of those parts and see how many of those 4700 picofarad caps were actually bad in there. At the same time, I added the snubber capacitor down here in the audio section, got that done right down here. And there were some other 4700 picofarad capacitors down in the bottom here that I also changed out. This is one of them here that was changed. I don't know if you can see this one here. Can you see this one? It's this one right here. No, you can't really see that. It's under the shield. So let me tip that up. That one right there was changed. And then of course this other one that was noisy, that was right here, was changed as well. Is that one right up in there? So lots of them got changed out. Lots and lots of work done there. I sprayed down the entire band switch assembly with some contact cleaner. So that was really nothing major, just spray it down and rotate the band switch a whole bunch of times and then gave it just a little bit of lubrication. So the thing is really at this point ready to listen to. The only thing I haven't done is changed out this coil in the back here, and I have to remove a coil from another radio receiver to replace this most likely because it's pretty bad. So we'll take a listen to some of those crackly components and then we'll compare them to another AR-88, actually GR-17, close enough, a radio receiver with a different style of domino capacitors in them. I'll open some of those ones up and we'll see if those are noisy at all, just to verify whether this is maybe just a bad batch of capacitors. So if you have one of these radio receivers and you have these 4700 picofarad capacitors that this one has, this will give you a good idea whether you really need to worry about them or not. Look at all the 4700 picofarad capacitors that came out of this thing. Wow, lots of them. So these are some that were previously replaced. And I opened one up to show that they are an actual Mica capacitor inside, which they definitely all are. All the ones on the piece of paper here are the ones that were just previously removed. So this is the first RF box, second RF box, mixer oscillator box, and then some other ones that were lower down in the circuitry here, the BFO bypass. This came out of the cathode circuit for the meter, and this one was the AVC line right here. And the resistors we'll test in a moment. I'll show you some of the resistors that I've replaced here as well. So let's take a listen to some of these capacitors and see how noisy these are. These are all untested, and this will give us a good idea how many of these 4700 picofarad capacitors are actually bad. So this here is a Heathkit signal tracer, and it has a noise function. So what it does is it puts B plus across these two leads, and right now it's in tracer mode, so there is no B plus. So you can hear it's on. So when I turn this into the noise position, it'll apply voltage to these and it'll listen to the component here. So I'll turn the gain down, I'll grab the first capacitor, and let's take a listen to it and see if this one is noisy, and we'll just work our way around. Okay, so there's the first one. All right, so turn the gain up, turn it to noise. Wow. I definitely say that that's bad. So you know that that one's bad. Let's take a listen to, well, let's just stay in the first RF box here. Let's see what happens with this one. Attach this one up. Okay, so here we go. Turn the gain up a little bit. Turn it to noise. Not bad. Oh, well, here we go. So it is noisy as well. Not nearly as bad as the first one. Amazing. So it is really starting to look like this is a bad batch. So let's go into the second RF box here. I'll attach this one up. Let's take a listen to this one, see if it's noisy as well. Okay. Turn that up. The little bit of hum that you hear is normal because of the open line here. That one's actually sitting pretty quiet. No static at all. Yeah. So there's one of them that might be okay. Of course, I would never trust it. Let's try this one here. This one is a different color than the rest of them too. This is a lighter color. Kind of interesting. Let's try that one. Okay, so here we go. Here's another one. Gain up. Sounds like a rainstorm. or rushing wind or something like that. Wow. I have to tell you, I've never come across so many bad 4700 picofarad capacitors. All right, let's try this one, the mixer oscillator. All right. That one's sitting very quiet. So not too bad for that one. So that one is on the mixer screen. Yep, nothing there, just open line hum. All right. Let's try the mixer cathode. So now this will be interesting because there's really low voltage across this. All right, so let's try this out. Yeah, it's noisy too. You can hear that. Listen to that go. It's starting to get real. Wow. All right, let's try the BFO bypass. All right, here we go. Just when you think it's okay, obviously definitely not to be ever trusted, right? So all the 4700s in here are bad. So I'm beginning to think that it's a bad batch. Even the ones in the low voltage areas are bad. Try the cathode circuit for the meter. Listen to that one. Wow. And last but not least, let's do the first AVC line capacitor here. All right. So again, this one here is in another low voltage portion of the circuit. Yeah, so not too bad with that one. Again, you know, of course I wouldn't trust any of these things, right? So almost all of them are noisy. Almost every single one of them. That's pretty crazy. So, I'll grab this meter here. Hopefully you can see this. You can see that. Zoom on in just a little bit. All right, so this is the 47 k ohm resistor in the first unit. So this is in the first RF. Let's take a look at that one. So not too bad, 49 k ohms. Again, it was changed just because it should be 33 to get the most amount of gain. So this one is the 47 k ohm in the second unit. So 52, 53 k ohms. Again, not too bad for one of these older resistors. This is the 33 k ohm resistor in the mixer box. That one that I changed way down underneath. So this 33 k ohm went up to basically 37 k. So I figured I'd get rid of it. And there is a resistor down at the bottom here, which is a 390 ohm resistor, which is the cathode resistor in the third IF. So I just went through and I just randomly started testing all of these resistors. And you can see that one's gone even past the next value up. So from 390 to 475 K, or 475 ohms, not K ohms, but just ohms. So that's gone from, 390 all the way up there. So that one got changed. So that resistor there, the third IF, is this right here. So move the radio around so maybe you can see this. And move the camera a bit. So that 390 ohm resistor is right there. That's the third IF right here. That's the one that got changed. I'll zoom on in just a bit. There it is. Again, don't be fooled by the sizes. These are older style resistors and these are the newer style resistors. So this resistor here is absolutely fine in its place. So there's 390 ohms, very accurate value because it has the red tolerance band there. So that one was replaced. All the rest of them are okay. You know, I tested the 33K. And this one here is a 680K ohms. 2.2 megs, 2.2 megs. 1K ohm down here is absolutely fine. I don't know if you can see there's a 390 K ohm resistor here. They're all okay. So, you know, no problems with all the rest of them. I went through the entire circuit and tested all of them and the rest of them up in the upper boxes as well, just to make sure that everything is within spec. Again, you know, we want this thing to receive the best that it can, right? So all in all, that's doing okay. So now what I'll do, so this should be a lot of fun, is I'll move the GR17 into the shot here, and what I'll do is I'll open up some of the Mica capacitors, some of the 4700 picofarad capacitors in the GR17, and let's compare them on the Heathkit and see if they're actually noisy as well. This should be very, very interesting. All right, meet the GR17. This is the other receiver that you saw in the intro picture. So let's see if this is going to have enough heat to do this. I need to add some solder to this to make this happen. Let's see. We can probably need to add some solder here. A lot of the times you have to add solder to remove, just so that way it makes good thermal contact. By adding solder, you kind of blend it in with the old stuff. All right, there it is. All right, there's one. So do you think we should remove some more here? Maybe this one up here as well. Let's try this one. I have another iron that is very, very hot. I have set up for this, to do this. So this one here I grabbed. This one seems to be doing okay. We have a little thermal relief, like little tabs here, that provide just a touch of thermal relief. Being a little bit fussy. There's another one. There's another one here. It's pretty tight. I don't know if I'm going to be able to get this one out. We can go across these two here like we did in the other receiver over here and see if these are noisy. So I'll see how that works out. Pardon the background noise. There's some traffic making a lot of noise outside right now. Okay, so let's see if these two are noisy. Let's move this out of the way and clip this onto here. So the ground end, or the common end, will go into circuit, and then of course the signal lead goes to the floating end. So I'll turn that on. Here we go. I'll move the camera so you can see that. It's in noise mode, dead silent. That's full gain. If that was to start crackling, that would probably put me across the shop. It's so noisy. Okay, so back into tracer mode. No noise with this one. All right, here we go. To me, it's looking like a bad batch of capacitors. These are different Micas. Again, as I've said in many of my other videos, Micas rarely fail. The one in IF transformers do, the ones that are kind of compressed between plates, the little molded ones in the bases of the All-American 5 and All-American 6 IF transformers. Those are pretty bad. Sometimes referred to as silver mica disease. So basically it's just compressed between a bunch of plates, and they oxidize and you get this crackling and all that kind of stuff. So that is pretty common, but these molded mica capacitors usually are fine. All right, 2 for the price of 1. Let's test both of these 4700 picofarad capacitors and see if they are noisy like they were in the other radio receiver. Same test setup, same way, everything. And this is going to apply B+ across these 2 capacitors and listen to them. So here we go. I'll put it into noise mode. Turn up the volume, the gain if you prefer. That's full, like that's cranked right to the top. So there's no problems there whatsoever. Again, pointing to a bad batch of capacitors in the CR-88. Again, that hum that you're hearing and everything is normal because of the line here and everything like that. So turn that back down, turn it back into tracer mode, so when I disconnect this, I don't give myself a good buzz. And look, see this capacitor right here? This is the destroyer of audio transformers right here. You see this one? If you find this in your AR-88, CR-88, whatever version of this radio receiver that you have, 0.003, 1000 volts, when this capacitor shorts, what it does is it drags the plate side of the audio transformer right to ground. So you have full B+ on one side of the primary, and on the other side of the primary, which goes to the plate, it's dragged right to ground. So what happens? Well, these things, they just burn right up. So this capacitor is bad news. So it'd be interesting to open this up in this GR17 and see how bad this capacitor is. So I've replaced this one. See, it's a 1000 volt rated capacitor, 1000 volt part here. I replaced this with a 1.4 kV disc. So those are very resilient. The value that I replaced in mine as well is 0.0022. This is a 0.003. So the 0022 is absolutely fine in this application. So yes, very bad component, and it's still in circuit. This again looks like it might be a factory part. Probably is, because it's the exact same reading that they have on the schematics. Another thing to note, you see these seals on these bathtub style capacitors? As you can see, they're going away and they are starting to leak. So they shouldn't look like that. Looks like orange silicone. And they're all doing that. You can see this one over here is moving around. Let's see if I can grab a Q-tip and see how. Yeah, nice and gooey. So at any rate, this is a standard for these bathtub style capacitors, and this is why they all need to be replaced as well. Those seals go away and they just start oozing all over everything. So there you go, GR17. This would be quite the restoration project as well, but this one here is going to be a donor for the CR-88. So I'm going to have to take some of the coils, which you see in this box over here. Take some of the coils out of this box here and most likely move them in. Pardon the camera movement here. It's camera's lifted up really high. So take some of these, and these will have to go into the other receiver. Here's a little bulb on the antenna line to protect the antenna line. That's something that the CR-88 does not have, and that might be one of the reasons that the coil itself is the coil forms are melted in the other one. Who knows? We'll have to inspect those. That'll be another huge job for me to do, to get all those coils out. I'll have to draw everything out and take all the coils out. So in this one here, you can see the coils on the bottom. So in this one here, right, and I have to get right down into this bottom section on the other radio receiver and pull this furthermost coil out. This one is a different coil completely because this is a different band setup, but some of these coils are almost identical, so I can get away with using some spares out of the GR17. All right, just for the fun of it, let's see if the transformer destroyer has caused any damage here. Let's see if this is going to show any leakage. Well, it made it through the first scale, so there's a good chance that that transformer's still okay. And we're on to the second scale now. And this is in the paper and poly position on this capacitor tester here. So, of course, it's still very leaky, but it's not leaky enough that it would destroy that transformer. So, on the second scale, still red, and at the top of the scale, this has to go all the way down, and then this turns green if it's okay. So, yeah. Well, at least I know the transformer is most likely still okay. So, there we have it. That's nice to know. Here's another little trick to test an audio output transformer if you want to be absolutely sure. So with this capacitor disconnected in circuit here, I have this focused on here right now, but with this capacitor disconnected, I can take the LCR meter and I can go right across the primary winding here. And so what I'll do is I will show you exactly what I'm doing. So I need to put this, hopefully I can get this all into this picture here. There, and this is the plate side. Okay, so there we go. So this has got an open secondary right now, right? And because it's a transformer, in order to get a correct reading, we need to have a load on the secondary side of the transformer. All right, so as you can see, we're dealing with about it looks like almost 400 k ohms, right, with an open secondary. So it's a 2.5 ohm secondary on this. So I have a 2.7 ohm resistor, which is close enough to get an idea. You can see that there, so a 2.7 ohm resistor. So let's take a look at what happens here when I attach this onto the back side here. Again, you need to load the secondary because it is a transformer. And it becomes 8 k ohms, which is right about okay for a 6K6 output tube. So no problems. So the audio transformer is doing absolutely fine in this thing. So there you go. One of the benefits of having an LCR meter around, you can just test your transformer just that easily. All right, let's give this radio receiver a performance check and see what a difference changing out all of those components has made. I have a feeling that just changing out those two 47 k ohm resistors to the two 33 k ohm resistors and the two RF amplifier boxes is going to make a big difference in the receive. So it should strengthen up the RF amplifier section quite a bit. So it's in the broadcast band right now. It's pointed to band number 1 here. The audio gain is right down, RF gain is up. This is in the broad position, the selectivity, so it should be fine. AVC and antenna is about halfway, so that's fine. So I'll just turn this on, let it warm up for a few moments, and we'll see how well it performs in the broadcast band. This is hooked up to the 369 antenna as well. I really like the look of these orange dials. It looks really, really nice. Fortunately, somebody cracked the plastic dial face. I was hoping to take the dial face out of the GR-17 and use it in here, but I found out something kind of disturbing. Somebody glued the S meter directly onto the dial plastic in the other one. So I'll have to look for yet another radio receiver with a nice dial that I can use to, replace the dial plastic here. So that's unfortunate. So I'll be using coils out of the GR-17 and a dial face out of another radio receiver. So again, this is going to be the one that's used for comparison in the Grand Receiver Restoration Series. So this one has to perform at its max, and of course this is the one that's going to be restored to the max here. So may as well just go all the way and replace that with something that looks very, very nice. Again, I might use one out of an CR-88 because it's black, and I think it would contrast this quite a bit nicer. You got the black knobs, you got the gray face, and then having a black dial would look, I think, much nicer than the gray. Much, much nicer. So anyways, we'll see. And if I don't like it, I'll just order up another one of these from somewhere, I guess. All right, so let's see how this is going to perform. Turn this up. Look at that. Hardly any audio gain. And that's loud coming out of there. So peek up the antenna. It's about fine.
6, Scottish writer Robert.
Wow.
Yeah, info at. So I think
beaches, a lot of people are trying to repurpose it for things like fertilizer.
between rent. We'll listen to RCA.
Ways Committee will hold a public
get to her in a 3%. The 3%. Well, European office attendance is closer to 70%.
That's a pretty strong signal. So the broadcast band is working great. So let's try number 2. Lots of gain there. Whoa. All right, so with that much static, we know that this thing's receiving like crazy there. Go there. Look at that. WWV. Should get a voice anytime here. At the tone. Where is it? Not yet. At the tone. There we go. Wow. So this was the band that was quiet. So let's see. It's alive. Wow. So the band has come to life. So action in number 5 now. Turn that down. Go to number 6. Yeah. So every band is alive now, and it's receiving very well. There's been no IF alignment, no RF alignment, no oscillator alignment, no anything. And you can already see by just changing those parts how this thing is waking right up. So next, I'll be addressing the coils on the back side here. We'll be removing the face off this thing. We'll get in here and we'll clean the chassis up. And after that, you know, of course, this is going to get replaced and lubricate everything up on the front here. And then it's alignment. So the end of the CR-88 restoration is very, very near. It won't be much longer now. And we'll get to see how well this thing performs when it's completely tuned up. So I'm looking forward to that. That's coming up next. If you enjoyed this video, or you're enjoying my videos in general, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at vacuum tube electronics and solid-state electronic devices alike. There'll be a lot of repairs, restorations, circuitry design, troubleshooting, and all of that great stuff on this channel. So if you're all about electronics, like I'm all about electronics, this is the place you want to be. Don't forget to subscribe and tap that bell symbol. That way you'll be notified as soon as I post a brand new video. I have an ongoing electronics course on Patreon where I have a lot of extended electronic knowledge being shared there. I also share many of my personal electronic inventions and designs there, many of which you've seen me use on this channel multiple times, just because they are so incredibly handy. When I design something, there's usually a necessity, and because there's a necessity, I'm using my own designs all the time. So I really find these little devices that I've created handy, and you will too, if you're repairing electronics or troubleshooting or doing any of that stuff. Definitely check out Patreon. There's something there for everybody. Whether you're a beginner or you're intermediate, whether you're a technician or an engineer, there's a lot of great information up there. Check it out. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comments section. Click on the link and it'll take you right there. All right, until next time, take care. Bye for now.